Here is an example of computing conditional probabilities using a tree diagram. Ed's Tires and Brakes has two locations, one on the northwest side of town and one on the southeast side of town. At both locations are performed tire repairs and rotations as well as expensive brake repairs. This past week, 70% of cars serviced at Ed's were serviced at the northwest location, while 30% of the cars were serviced at the southeast location, and no car was serviced at both. Brake repairs were more typical at the northwest location than at the southeast location. 65% of cars at the northwest location required brake repairs, while 30% of the cars at the southeast location required brake repairs. Let N denote the event that a randomly chosen car, taken to Ed's in the past week, was serviced at the northwest location, and N bar denote the event that a randomly chosen car was serviced at the southeast location. Let B denote the event that a randomly chosen car required brake repairs, and B bar denote the event that a randomly chosen car did not require brake repairs. Fill in the probabilities to complete the tree diagram below, and then answer the questions that follow. Do not round any of your responses. So let's take a look at our tree diagram first. We have very clearly defined variables which were chosen for us, and we need to operate using those. So N stands for cars that were serviced at north west location, and N bar meaning those that were not serviced at northwest location. Therefore, those cars were serviced at southeast location. And again, those that required brake repairs denoted by B. Those that did not require that repair denoted by B bar. Okay, so probability of a car serviced at northwest location is 70%, and that comes from this statement right here. 70% of cars were serviced at northwest location. 30%, obviously right here, will be serviced at the other location. So they are serviced either at first or second one. So we can fill in this blank right here. Probability of N bar is 30/100th. Then we continue, and we know the following. 65% of cars at the northwest location, meaning given that they were serviced at the northwest location, 65% of those required brake repair. So that's how we can fill in this blank right here. Please notice that when you add these two probabilities, you should get 1, because we should be exhausting all the options by now. The cars were either in one location or another, and combined together, we're gonna take the entire 100% of cars we're considering at this time. So as you can see right here, 35/100th for B bar given N combines nicely together with the 65% we place right there. Using the same logic, we can fill in the 70% over here. And if that makes any difference, I'm going to put a 0 here to be consistent and have 2 digits after decimal point in numbers that I have used so far. Okay, let's continue. Now we are asking ourselves the question, what is the probability of a car being serviced at northwest location and having brakes fixed? Well, if you use the tree, you just need to go along the path that you took to get here. So first number on that path was 70% of cars ended up in northwest location, and out of those, 65% of cars were getting brakes fixed. Multiply these two numbers to get your intersection, and that's what the result going to be, 455 thousandths. Similarly, 70% multiplied by 35% will give me the probability of N and B bar to be 245 thousandths when I multiply these two numbers. To get the other two results, we multiply 30/100th by 30/100th to get 9/100th as probability of N bar and B. And finally, 30/100 multiplied by 70/100 will give me 21/100, which is the probability of N bar and B bar. Now that we've filled out all the required information in the diagram above, we will attempt to answer the question given to us right here. What is the probability that a randomly chosen car did not require brake repairs? Which means we would like to compute the probability of B bar. Probability of B bar, or not getting brakes fixed, really is made of two pools because we have two locations. So we need the probability in one location of cars not getting brakes fixed, plus the probability of the second location of the cars that didn't get their brakes fixed. So we will combine these two probabilities. And because we had this little statement over here which says no car was serviced at both locations, we do not have to worry about the potential overlap between these two probabilities. We can go ahead and just add them together, and the combined sum is 455 thousandths. In other words, 45.5% is the probability that a randomly chosen car did not get brakes fixed when it was serviced at any of the locations of Ed's Tires and Brakes business.